As I say, thank you so much for coming to the last session today, which is software architectures and software design engineering. We are going to have only 4 presentations. Architecture on knowledge management systems is present in academic literature. Automatic location and suppression of calcification and atheroms by gradient change in pattern of intensities inside the carotid artery. Introducing planet-saving strategies to measure, control, and mitigate greenhouse gas emissions and water misuse in household residences. Team productivity in agile software development, a systematic mapping study. The first 3 sessions, we are going to have people talking. In the last session, we are going to have a video. So, well, hopefully this thing is going to go really fast today. And the audience here is going to pose a lot of questions. Thank you so much for coming again. I don't know if the room, we have only 10 participants. Anyone speaking French in the room? Okay, that's good. Je vous remercie d'avoir venu ici. On a la dernière présentation aujourd'hui. Il s'appelle Software Architectures and Software Design Engineering. Vous pouvez poser des questions que vous voulez en français. On va faire la traduction ici. Merci beaucoup. Okay, Architecture and Knowledge Management Systems. Its presence in academic literature. I need to know if the author is here. Authors are, okay, Luciano.
Yes.
Thank you so much for coming, Luciano. How are you?
Thanks.
Okay, well, we have sound. Thank you so much. That was a test. It's not that I am polite. It was just a test. Thank you so much. Okay, I'm going to open the systems. Let me corroborate that everything is working.
Okay.
Okay. We have online translation. It's gone. Okay, Luciano, the screen is yours. I will let you work then. Thank you so much.
Okay. Do you see my presentation? Yes, it's okay.
Luciano, could you say something? Luciano, we know each other with Luciano, isn't it? I know Luciano. Luciano, my good friend, how are you? We need to make a sound test. Can you speak anything in any language?
Yes, it's okay. I can speak in English, yes. Okay, yes. I can receive a message.
Give me a second, Luciano. Okay, now we have sound here. I was talking to...
Okay.
Okay, it's a technical issue, but we already solved most of them. Say something, Luciano.
Yes, it's okay? Now?
Go ahead, man.
Yes? Okay. Correct. Do you see the presentation now? Yes, it's okay. When you say me, I can start.
Okay, Luciano, we're ready.
Right, okay.
Everyone is watching you.
Okay, thanks. Well, I'm Luciano Estraccia. I am a member of Grupo de Estudios en Metodologías de Ingeniería de Software of Universidad Tecnológica Nacional from Buenos Aires. The co-authors are María Florencia Pollo Cataño, Matías Giorda, María Gracia Bongiorno, and Adriana Maulini. Our research line is knowledge management, and in this case, the paper is about architecture and knowledge management system with us an scoping study. The title is Architecture and Knowledge Management System is present in the academic literature. As the schedule, I will speak about knowledge management in general, about architecture and architecture for knowledge management, and will present the scoping study and its results. What is knowledge management? First, the knowledge is a part of Hackov hierarchy. The hierarchy that Hackov proposed is data, information, knowledge, wisdom. We focus is knowledge, but what is information? Information is a function of data. If the data gives a meaning, if you give meaning to this data, the result is the information. In general, this is the discipline of information system. And what is knowledge? Well, the knowledge denotes or the function of information, denotes the processing function that returns knowledge by making sense of information under its context. In general, the knowledge is defined that information plus context, in a context, plus insight. And the term insight is very important for the knowledge because represent the tacit implication, the tacit knowledge, the other way to transfer knowledge between the people in one organization. For the submission, the knowledge management is the mixture of, the knowledge is the mixture of cognitive and contextualist beliefs, perspective, judgment, methodology, information, experience, expectation about an object, which is adapted and empowered by the people mind. There are two concepts very important in this definition: the perspective and judgment experience, and the people mind. It's very important for the knowledge consider the people and his experience. And the knowledge provides the basis for generate a critical view of the environment. It's possible that the environment can be understood and interpreted through to knowledge for Martinez. What is knowledge management? Well, if the knowledge is important for the organization, then it's necessary manage this knowledge. The knowledge management is a process through which the organization can discover, use, and maintain the knowledge for aligned to the business strategy to obtain competitive advantage. For Pérez Urubae, the knowledge management is an emerging discipline for exploit the knowledge generated to achieve the organizational objective and optimize the process of decision making. Characteristic of the knowledge management is that we say that the knowledge management is multidiscipline. One discipline is informatics. The knowledge management have 5 views or 5 point of views. The people, the organizational aspect in general, or organizational culture, or leadership, include the motivation and other aspects in the organization, the process and activities and tasks, the measurement, and finally, the technologies and knowledge representation. Well, the knowledge management system suppose they consider the 5 view, and our scope is technology and especially the architecture for knowledge management. Then what is architecture? Architecture, how the system is structured and the way its components work together. Our definition is that an architecture is a system model within a specific context, representing the components necessary to develop the system from a particular perspective or point of view. And a system architecture includes the structure of the core components, their characteristics or properties, as well as the relationship and interface between the component and external entities. The architecture needs components, the relationship between components, the component properties, and define the interface between the components. Then, and there are several architecture types. For Medina Garcia, there are 2 types or 2 styles. The classical architecture, the author Medina Garcia say that the classical architecture are generics, and the other type is proprietary architecture. Proprietary architecture is if the one specific software or one specific organization, and classical architecture is generic standard for several organizations. For Medina Garcia, the classic architectures are a lawyer style or lawyer architect. I will speak about this concept of lawyer architecture. In this paper, we will consider three types. The proprietary architecture for a specific software or for a specific organization, the lawyer style, and the non-lawyer style, other style for architecture. What is a lawyer architecture? Well, in the discipline, the lawyer architecture is the most common architectural pattern and is known to as the entire architectural pattern. For example, OC for communication, telecommunication, and it's in software design. In software design is used with in general with a presentation lawyer, a logical lawyer, data lawyer. In the last model to the view lawyer and data lawyer and business or logical lawyer. And the components within the lawyer architecture part are organized into a horizontal lawyer, each lawyer performing a specific role within the application. Which lawyer or which component it has a specific role, and there are a relationship between the lawyer. And this lawyer have an order and a dependence on each lawyer. One lawyer has a result, and the result is the input for the next lawyer. We release a scoping study. The method for scoping studies: identify research questions, identify relevant studies, do the study selection, chart the data, collect summary, and report the results. Our research questions are: how many papers associated with knowledge management deal with software architecture? There are several papers about knowledge management, but how many papers associated with this line deal with software architecture? What types of architecture are presented in the papers found? And what information about this architecture are presented in this paper? This is the research criteria. This is the exclusion criteria, papers that use knowledge management with a different scope, or paper but don't make specific reference to any of the views presented in the background, or paper that not present any technological architecture were excluded too. And this is the result. The title correct is result. The results, there are more 100 results paper for this, but with the application of exclusion criteria, our result is only 14 papers. And if we read these papers, these are the papers found, different authors. And our method was chart the data, the type of the architecture, if whether it defines generic and a lawyer, or generic non-lawyer, or proprietary architecture, whether it defines components, where it presents the relationship between components, only for a lawyer architecture, for tire architecture, where it presents the relationship between components of the same lawyer, because one important topic is that the architecture requires components, and in one lawyer, you have several components. Then the question is if this architecture presents the relationship between components of the same lawyer or between components of different lawyers. This is the the result of the analysis. Yes. And this is the detail for the paper. In Moscoso Sea, there are a higher level architecture, enterprise architecture software, but not about application architecture or infrastructure or other viewpoints in the architecture software. Gutiérrez Bogotá's architecture is all an enterprise architecture. Tinsu especially analyzed a proprietary architecture of software called Kaitoro. The architecture of Zavala, Joffre, and Aitao are based on Kircher proposal. Kircher is a lawyer architecture, most frequent architecture for knowledge management with the presentation knowledge management lawyer in place of the logical lawyer in the software production, and data lawyer. Pastrana, Cruz, and Sanchez Valencia present their architecture with the same lawyer. There are 5 papers based on Kircher proposal. Ruiz and Liu present architecture based on different knowledge management activities, but don't have a specific application or doesn't present technological elements in the architecture. And Tedesco proposed an architecture based on the constructivist vision of knowledge and the Akov pyramid. Tedesco proposed different technologies for different levels of the hierarchy, some activities or some technological elements for data, others technological elements for information, other for knowledge, another for wisdom. The conclusion: the architecture of knowledge management is a poorly investigated topic in the bibliography of knowledge management in the search consultant. In this work, most of the knowledge management architecture found a lawyer architecture with 3 styles for defining the lawyer. The first is a traditional way associated with software production, based in Kircher. The second defines 1 layer for each knowledge management activity, and the last associates a lawyer with the levels of the Akov pyramid. The intention for the future is propose other possibilities from architecture, from different architecture for knowledge management. Our next work will be other scoping study about the European studies. In the future, the next year, we'll propose some architecture for knowledge management. Well, thank you.
Thank you so much, Luciano. I guess the audience hear you very well, so I'm going to open the space for the questions. Any question? ¿Alguna pregunta? Questions? Flor? Preguntas? I got a question for you, Luciano.
Okay.
I know that this is the beginning of a research. You are doing a systematic review. But right now, you must be ready to answer this question. What do you think you can do with this knowledge that you just acquired? ¿Qué crees tú que puedes hacer con lo que has aprendido en esta investigación preliminar que hiciste?
Our intention is identify in the future different technological elements, because one problem of the architecture is that the architecture for his application really is define his components. If you propose an architecture but don't propose a technological element, it's impossible apply in the organization. Then the intention is in the future propose an complete architecture with the different technological elements and consider the characteristics of the organization. In general, the architecture is proposed in generic way for a few of organization for a industry, but in the real life, the organizations are different, and it's necessary propose different architecture for the different organization, consider his resource and his possibilities. Then the idea is evaluate the different characteristic variables, resource, etc., and propose a different architecture or one generic architecture with his possibilities of change.
Thank you so much, Luciano. Any other
Thanks so
question?
much.
Flor? She said that she got a conflict of interest. Okay, thank you so much, Luciano. That's
Thanks so much.
the Argentinian presentation, and we move forward to myself. What is the one? Excellent, Luciano.
Thanks.
Estoy patinando. ¿Listo? ¿Sí? Ah, no, no, espera, espera. Mándame alguna señal si acaso voy muy rápido. Mándame alguna señal si voy muy rápido. Sí, ¿para qué? Esas dos que siguen son míos. Soy yo el que va a hablar. Es un video. No.
Yo lo ayudo, ¿qué pasa? Yo lo ayudo.
Excellent. Okay, we are going to move forward to the next presentation. I'm the author of this work, so I'm going to wait for the authorization of the online translation, and I will start over. Excellent. Okay. Early this morning, I was talking about this problem, which is a very, very hard problem for humanity because this thing is killing humans. It's about coronary and artery disease called atheroma or blockages. Blockages in the blood fluid going to the brain. Be careful over there. Let me see if I can move forward with this control. This doesn't work. No se mueve. Alguien le tocó el cosito. Okay. I'm going to use the same background information that I used in the previous presentation because the people that I see new faces, so I want you to get involved. This is the problem. Those blockages in the carotid artery might happen either in the internal carotid artery or in the external one. Those things are included in your neck. And the problem is that because of the bad habits, bad food, no sport at all, you start accumulating that corrosive substance in the vessels. And that creates a blockage. Your blood cannot flow properly to the brain. Excellent. So this is a 3D representation of what happens inside the vessel. It gets constrained and the flow changes. That means that less oxygen goes to the brain. These are all the information that the doctor gives you. Where it happens, I already told you in the neck. What? Well, it's because that blockage is created with fat, cholesterol, calcium, connective tissue, and inflammatory cells. What it causes, I won't read it, but I'll tell you. You will feel it if you don't take care. The sensation of dizziness, people used to associate it to the urine. Might happen, but might not. It could be the blood not going well to the brain. Also, the capacity to see, speak, walking, Whatever happens in the brain gets affected. The problem is that the affliction is random. So it could happen anything. 1 of 3 deaths in North America, and we know what happens in North America because they got the statistics. We don't know really what really happens here in my country. But 1 of 3 deaths in North America happen because of this pathology. So that's why this is very relevant. Why? Why it happens? Well, as I told you, bad habits most of the times. But age is a factor. Male sex. There are people talking about gender right now. Well, male sex is a problem. Being a male is bad regarding this pathology. Smoking, hypertension, poor diet, low physical activity. I put high cholesterol twice because that's the most incident and because I made a mistake. Critical situations, an embolus. Well, when I say embolus, people think about something special. Nothing like that. The embolus is a part of the blockage that gets disconnected, detached, and goes to the brain. It is really bad because the vessels in the brain are very small. So the blockage creates what we call local ictus. And the ictus is the pathology that constrains the most the humans. Severe stenosis means that the vessel is getting so close that the flow cannot go properly. We consider a severe stenosis when 70% of the vessel is blocked. I'm sorry I didn't warn you about these images. We showed them in the morning. I'm gonna go really fast. When you go to the surgery, because that's the procedure, when you got a severe stenosis, the procedure is this one. You start opening the neck, you expose the artery over there in the second frame. You need to grab all the arteries because the idea is that you are gonna work without the fluid. So those blue and white straps, they're blocking the flow. Over here, you must be able to see this thing. It is a tube. That tube is making a bypass. So the blood is flowing over there. That means that the person that is receiving this surgery, of course, is alive, but is still pumping, you know, his hair is, or her hair is pumping. And once you have all that done, what the doctor is going to do is to use this tool in order to grab the pieces of gross substance and take it outside manually. Very dangerous situation because you leave something inside that's gonna affect your heart or your brain. Okay, images, this is part of the background. This is a echography, this is echo. So you can see the blockages. This is the external carotid, and this is the internal carotid. I don't know if you see the space over there, it's smaller. And this is a blockage. The reflection of the blockage is different, and you can see it in blue. This is not sensitive. You know that something is happening in the artery, but you cannot quantify how much it is. In order to do that, you have the CT. This is an angiography created with CT. CT is ionizing radiation, so it creates cancer. I never suggest doing this test because while you receive while you receive more and more radiation like this one, you are more prone to develop a cancer. But anyways, it creates beautiful views. What is the problem? Can an automation detect the plaque? Plaque is the blockage prior to launch the center line algorithm, and there is a background here that I am lacking. I missed something. The center line algorithm. I'm gonna go backwards. If you want to characterize the plaque, you need to do a center line. And why you need that center line? Because this volume is created with the slices. So you go to every slice, and you need to know a perpendicular plane to the vessel. So that's why we create a center line. This is a very well accepted algorithm, has been in the market for about 20 years, And well, doctors feel very comfortable with that. When I say doctors, I mean physicians. So you see the plane, there is a problem here in the second frame. The plane is supposed to be perpendicular to the vessel, and that plane is not perpendicular. You see? There is a projection. And it happens because that part that is kind of hidden, that's an atheron, that's part of the plaque, and it makes the centerline algorithm goes anywhere. I will show you a more critical representation later. So again, the question is, can an automation detect the plaque prior to launch the central algorithm? The idea is to take it out, to take out the blockage, and then run the algorithm so it can go straight forward. Sorry, how to assure that the algorithm can estimate the correct plane for analysis? Now I'm talking about the plane. If the line goes well, the planes are gonna go perpendicular to the vessel. Even if the vessel goes like this and the center line is well calculated, the plane is gonna go perpendicular to the vessel. Look at this problem. This is when the algorithm becomes crazy. And it became crazy because there is a blockage here. I'm gonna show it here. And that blockage makes the algorithm do crazy things. The planes here are very difficult to detect. I mean, the planes goes like this. It goes around. So this is the approach. I'm gonna be very short. Hopefully you will understand what's gonna happen. A lot of mathematics involved here, so pay attention. Let's take the plaque out before launching the central algorithm. I already said that. You take out the plaque and you fill that hole with the same intensity of the vessel, of the artery. Right now, the artery doesn't call anymore artery, it is called lumen, okay? Okay, it's a long, long process, but let's go straight forward to the images. This is how you look at the image. This is an axial cut of the vessel. When I say axial, the vessel is a tube, and you cut it in this way. Not side by side, but in this one. You see, like a piece of bread, you cut it like that. And then you need to go upwards and see it from top. You are watching the vessel from the space where the blood passes. It seems like you are part of the blood and you are passing through. So what we do is to open the whole image. Everyone does the same thing, and I'll tell you why. Because working with images is very heavy, very heavy. Computers can get stuck by working with these images because of the resolution. So what you do is to open an image. What I mean by open an image, this is a closed 2x2 matrix. So what you are going to do is to make the matrix to look like an array, like a vector. So it is linear. So what I'm showing here is the vector representation of this image. Then you need to apply this filter. I'm always having problems explaining how this filter works. It's a low-pass filter, but my friend mathematician can help me here. When you include parts of the solution in the output of the filter, that means that this is a recursive filter. It uses part of the output to feed himself. It's a recursive filter. In programming, I guess the most difficult part to do is recursivity. It uses part of the outputs to feed the new input. And this is very, very effective. The problem with this filter, let me show you when you see. This is the output, Y. You see, Y are the outputs. And this is a delayed output here. And these are the inputs. So that's why I say that this is recursive. A lot of mathematics. The problem with this filter is that it delays the image. In this case, 6 samples. That's why you see the blue line, which is the filter, a little bit forward in comparison with the one with the scale. Then you need to get that signal backwards. It's very easily accomplished. Just press six samples and it will go backwards. And this formulation is the formulation of an envelope detector. What is an envelope detector? Well, you got the signals over here, and the envelope is the blue one, okay, the blue signal. Then you're going to apply something called gradient. When people talk to you about gradients, this is the formulation. It's just a derivation or a differentiation. And this is the emphasis in big changes. How do you make the emphasis in big changes with a power of 2? Well, you try to put everything below 1. The things that are above 1, when they get operated by the power of 2, they get amplified. But the ones that are less than 1, they are going to be diminished. So with one operator, you make the big changes to go up and the small changes to diminish. And the last equation is something crazy that we call a moving window. So you do the integration in a moving window. And this is the result. The profile in red is the original profile. And the signals in blue are your picks, or not your picks, the algorithm picks. And I will show you how it looks in the image. Okay. This is a vessel that has a big atheron, a big plaque, and this is the algorithm picking up that plaque. Same thing happens over here, same thing happens over here, and over here. And this one is where I show you that there is a sane artery. That means that no pathology is in that artery, but what happens is that the algorithm tries to recover information from it. So the big limitation that this algorithm has is that it picks information from sanity, and it's supposed to work only when there is a pathology. It wastes time. Regarding the other scenarios, that's good. That is what the algorithm is supposed to do. So you can recover that information, and when you know where that information is located, you feel it with the same intensity of the vessels, of the lumen. Lumen is this part. This is lumen, this is the blockage, and this is background. So you now know where the blockages are. You just feel with the same intensity than here. And then you run the center line algorithm, and it will go smoothly through the center. Okay, conclusions, as I told you, very short. The created automation is fast. Yes, it is fast because you go to the domain of the array instead of working in the domain of the image. Also, the formulation is easier. If you work with the images, you will need to work in 2 dimensions. It avoids processing overload of the 2-dimension exploration. It can be used recurrently to separate other regions of the ROI. Now we separate the, how do you call it, the plaque, the atheron, but we can separate part of the vessels as well. So you do it in this way. You retard the plaque, you run it away, you retard the lumen, and at the end you are going to end with the background. It has been tested in several volumes. Yes, this is being used. This is not something that we are planning to do. This is already working in the hospital. So this is applied research. After this algorithm runs, the separated zones can be replaced with the desired intensity, as I told you, in order to make the center line go smoothly. The center line is benefited, of course, as I told you. It will go with the vessel and not with the, we call it, how do you call the things that are not part of the image? Don't remember the name. Well, it doesn't follow the things that are not the ones that we want them to follow. And the center line is still required to represent the quantifications, there is a mistake here, refer to the area of the artery. Only when you run the center line, you can get the plane. And when you get the plane, you can quantify what is in each plane. So the algorithm that I'm presenting here is an assistant algorithm to make the center line goes. It doesn't get any information from the image. Okay, I'm done. Any question? Mr. Hector, of course. All clear with the translation? Okay,
Thank you, Fernando, for the presentation.
give me a second.
Right?
For the people that just came to this presentation, if you are having problems with the English, you can go to the interpretation icon over there, click in and listen to this presentation in the simultaneous service that our friend is giving to us. Thank you so much.
Thank you. Well, this is kind of complex presentation, actually. I don't know, you are showing some results, mathematics results, and it looks like very complex, I guess. My question is, well, I understood that you got those results, and those results can be used by doctors when they have to use the surgery. Is that okay? Before they make a surgery to the patient, but my question is how these results support the doctor before the surgery.
I'm gonna open my microphone. The good thing is that the mathematics is just for you, people that are very smart. Physicians, they don't want to know anything about mathematics. They just make a click and the atom disappears. How they get help? First, the location. When you go to the surgery, the system tells you where the atom is located. And also, even before you try to make a surgery, you need to know if the stenosis, the blockage, is more than 70%. And for that reason, you need to quantify first. So you need to get the image, from the image, how big is the blockage. And this is where these things come handy. It's not for the surgery. It's in order to know what is the procedure, the best procedure to make. Okay, good? Hardware. When we work in 2D, I don't know what kind of computer you can use, but you know, it depends on the processor, because in these things you don't need much memory. What you need is a lot of processing power. Okay? When you put it in array, vector, it goes really fast. Okay. And you might say, it's the same thing, it's the same information, where regarding the processing power of the processor, it sounds redundant, but it is not. It's easier to go in an array than in a matrix. Any question over there? ¿Alguna pregunta de ustedes? ¿Les gustó? Ya les digo, pónganse pilas porque eso le pasa a todos los humanos. Cada vez que abrimos a alguien, tiene de eso, ¿sí? Y bueno, depende de qué es lo que comen, depende de cuánto deporte haga. Y sobre todo, estos muchachos que están en sus 20 años y ya tienen barriguita, ojo con eso, porque eso se correlaciona con problemas acá. Hacer deporte, ahí están ellas reídas, viéndole la barriga a los amigos. Bien, por favor.
Thank you very much for your conference.
Thank you for speaking in English, and I congratulate you. Very well.
My question is, this problem is physically visible?
Problem is physically visible? No.
No, it's visible.
What do you mean? From outside? Like if I have the problem, you can see it right now? ¿Quieres decirlo que si se ve desde afuera?
Yeah, can I see in the mirror this problem?
No, you won't see it from outside. You need a very specialized imaging process which is called computer tomography. Okay?
Yeah.
And let me tell you this, it's not just computer tomography. If you use computer tomography alone, you won't see anything. Let me explain this. Give me 1 minute. When you use computer tomography, those are X-rays that are projected in several lines around you. When you are inside the CT scanner, computer tomography scanner, it goes around you taking pictures. So it recreates the volume. But what happens? Most of the soft tissue is invisible, the same color for the system. you need to apply something called gadolinium. The gadolinium is applied through a needle. So this test is a very disgusting test. I'll tell you why. When they apply the gadolinium, that's like metal in your vessels, fluid metal. So you start feeling a sensation of dryness in your mouth, and you feel that you are going to pee in the table. Sientes que te vas a orinar en la tabla, ¿ok? Cuando te aplican el gadolinio. Got it?
Yeah, thank you.
Okay.
And can I say that this problem is silence?
Yes, and it gets covered with other pathologies. Let me go a little bit further in this. When you are feeling dizziness, it overlaps with a problem with your hearing. If you feel like your mouth is not moving, you are not able to vocalize, people used to think that you have a problem with your brain, not with your vessels. When you feel like you are not able to see, people used to think that you got a problem with your eyes, where it could be the blood problem, the blockage. So the problem with this pathology is that it's very dangerous, it's a silent pathology, and it gets overlapped with other pathologies. Did I answer well?
Oh, thank you very much.
Okay.
Thank you.
I'm not a doctor, by the way. Any other question? ¿Alguna otra pregunta? What about the audience in online system? How many participants do we have? 21? Okay. Unfortunately for you, the next presentation is mine too. It's a completely different topic. That means that we do a lot of research in different lines of development. And well, I'm exhausted now because I've been talking for more than 2 hours, but I will do it well. ICAI residential. Okay, we're ready? Translation? Excellent. I'm going to speak both in English and Spanish, if you don't mind. I'm going to be using both. That's good. Okay, guys. I asked you professors to come over here or to invite you over here because this topic concerns you. This is very important for you. This is about the future. Yesterday, I talked about the CO2 problem in the atmosphere and the global warming. I guess you're aware of what is happening, or I don't know. I'm going to ask you in Spanish if you're aware of the problem. ¿Saben ustedes lo que está pasando con el calentamiento global? ¿Han oído de eso? Bien, your country is one of the best in South America doing something against the global warming. And probably you don't know that, or you didn't know that, but you are. So yesterday, I talked about the problem, and I say that there are so many things to do, and we are measuring well. But this time, I'm going to do the contest, and I'm going to talk to you about IoT, Internet of Things, that is going to help the systems to control the CO2 emissions. First thing that I'll say is that the industries that are here are pushing this amount, or this percentage of CO2 to the atmosphere. Let me know how the translation goes. It's going well? Translation? I'm going to assume that the translation is going okay. So we focus in this 10% of commercial and residential emissions. This means that the houses are pushing emissions to the atmosphere. And this is important. Why? Because the emissions are warming the globe. So we focus in those houses. This is the problem. We have 1.2 degrees in this moment. We are supposed to warm the planet only 1.5. And this is the problem with the water. So I'm going to jump directly because this thing we already knew it. I spoke about this yesterday. The problem, the regulation is no mandatory. So nobody obligates the companies or the individuals to do it. Adherence to the regulation is suggested to companies, not to individuals. Being compliant with the regulation requires a lot of work. The IoT fully automate, but can be expensive. And when I say can be, I mention also the opportunity that we have over here. Proposed architecture. This is to be placed in a home, in a house, and it's flexible. We have here 3 modules that we already developed, and you can add your module as well. People used to tell me that this is home automation. It is no. Home automation is consecrated to give comfort to the human. In this case, most of the system can do the contrary, take you off comfort. I'll talk to you about water consumption. So this system can block the water usage. Can say you cannot use more water because you already overpassed the limit. So instead of giving you comfort, you're taking your shower with hot water, and the system starts beeping, beep, beep, beep. In 1 minute, you are gonna run out of water. And that's not comfortable at all. So let me explain you this. This is, the modules are in the house. This is IoT. You can see and control the IoT from this panel. And they talk to a centralizer. I won't say the name because I'm in the conflict of interest stage. But in that centralizer, you can push information. So this system reads the information that is in the cloud and controls everything over here. This is just for local controlling and visualization. This device can read the electricity without being intrusive. This one reads current with a magnetic field or true magnetic field. Voltage is just read with a big resistor. But the good thing about this device is that it can also control. When I say control, it means that 1, 0 means that you turn on and turn off a switch. But PWM means that you can dimmerize the lights or the fans or whatever you are using. So you can control everything from your cell phone. When you dimmerize, you are saving energy. This one is the water control. We have a Hall effect sensor and also a device that can block the water pass. So you can control with this device not only the measurement, but also the usage. Same architecture, this system talks to the centralizer and you can control everything from your cell phone. And this is the one that measures CO2 directly. Okay. Same device. This is a very well-known device that is programmable in Python even. And it has a CO2 sensor, a temperature sensor, and a humidity and temperature sensor. Here you don't need to control anything because this CO2 is produced by humans and alive subjects in the room. So we cannot control it. The only way to control it is to tell you don't breathe more or don't do it that frequently. And that's useless. Okay, let's see the results. This video is a very, very early stage of development. So it looks like a very kind of, cheap. And actually it is cheap because that's the idea. We use the cheapest components in the market. Why? We want the people to use it in their houses. And why they are going to be benefited by this? These devices can read the CO2 production and make the humans living in that house to adhere to the regulations without moving any finger. Or actually, they just need one finger. I don't know if the sound is going to go.
Bueno, ¿el caudal está full?
Okay, I put it off. I'll explain you what's happening over there. As I told you, very artisan with a, how do you say, licuadora? With a blending machine there. Okay, the thing that is below the blending recipient is an scale. I order my college to set the system to just let out half of a liter. Half of a liter is nothing. It's almost nothing. I wanted to see the precision of the system. What is in the screen, this is the sensor, very, very inexpensive sensor, and this is the control, the closing and opening. And okay, that's what is going to happen, very short. The system is going to let out only half of a liter. There you go. So that's the precision. We miss only 0.006 liters in this proof, in this test. So that's how we control. It seems like a very easy to implement, but the control, the processor has artificial intelligence in order to set the system up. I mean, this is very cheap, so it's very variable, but with a artificial intelligence table, the system gets everything online. I'm going to show you the other one. Okay. Let me see if it goes well. Yes. This frame shows the interface of the centralizer. This is Evalua. And this frame shows a hardware. We got the boxes. Inside the boxes, this is the hardware that is inside, okay? And this hardware is located in Bogota, Colombia, and this software runs in a cluster in New York. I'm going to explain you the hardware. Very easy. This is an OLED, a display. This is the CO2 sensor, humidity and temperature sensor, and this is the programmable device. If you manage to see a kind of a spiral here, that's a Wi-Fi antenna. So this system can read the information and send it wirelessly to the centralizer. What I'm talking, this system is reading. You will see the readings over here. When it pop-ups like that, it's because it's reading and it's sending at the same time. It reads and sends, reads and sends. And this is a refresh that I do on the system, that I did on the system, and we passed from having 0 readings to have 6. And in that moment, everything started working as in Evalua. So these are the readings of the CO2 directly in the atmosphere. The regulations doesn't consider this yet, but in 2030, when the countries have to give the quantifications, this thing is going to be important. People think, or humans think, that the problem is caused by the companies. But I believe, and that's the hypothesis, we are part of the program. Okay? Okay. As you see, we can send that information to the centralizer. The centralizer creates these plots. This is the electrical energy consumption. Here is the voltage, which is pretty stable, and these are the current. Where you connect more and more and more devices to the residential outlet, what gets modified is the current, not the voltage. And this is the limit that the system proposed. You can modify that from your cell phone. And when you consume more than that, the system is going to stop all the usage. So you cannot use the energy anymore. This seems to be like hard, but it's going to be the future. You need to save. This is the water. Water works in a session-by-session reading. So you go to the bathroom, and this is the magnitude, and this is the time. So what we measure over here is flow. And this is the control. This is how much liters, in this case, but we want to put it in gallons, you can consume per session. So if you consume more than that, the system is going to get blocked, as we show in the video. And this is CO2, temperature, and humidity. Here is the temperature, pretty stable. This is the CO2 all the time going upwards. I'll tell you why. Right now here, as we are breathing in this closed room, or even with those openings that we have, we are increasing the CO2 level here. Conclusions. Data gathering is performed automatically, and this is very important because people used to lie in the reports, especially because this regulation gives you money. You can sell your savings. So you know what's going to happen. People will start lying in order to show that they save more. No opportunity to report by convenience, a complement of what I just say. Nobody is going to be able to report by convenience. The individuals can continue their routinary life. I'll tell you why. In order to open your knob, having water, you don't need to do this anymore. What you need to do in this architecture is to put your finger in a fingerprint. If you need to turn on these lights, same. You're going to put your finger and turn on the light. You put it twice and you turn off. Why we make it like this? Because the CO2 is not going to be attached to the house, but to every individual in the house. So at the end of the day, you are going to have like an account of CO2 tons. You are going to be doing something for the planet, but it's the individual, not the house. Later, and we envisage this, you can go to the supermarket and buy groceries or buy whatever you want with your savings. That's why we think it's going to be the future. I just mentioned the four ones. So the regulations can be followed effortlessly. That means that you don't need to do anything. What you need to do is to change the appliances in your house. We will do the job for you. Possibility to associate the CO2 footprint to individuals. As I told you, we can say, Madame Flor has a consumption of 30 tons of CO2, and that will be like a coin, like money. Evalua Data Centralizer is an open source application. You can use Evalua whenever you want, for any purpose. We use it for this one in particular, but you can use it. It's open to everyone. Okay, thank you so much. Any question?
Has anybody any question?
Thank you, Fernando. I have a question, please. I didn't understand about Evalua. Where is installed, in the cell phone or the microcontroller?
Both. Evalua is the data centralizer. It's online. You can, I don't know if you help me here, Flor, so we can show the Evalua interface. It's online, and you can have it also in your phone because we have applications to feed the information to Evalua and also to see the reports. It works for Android and Apple as well. Any other question? I'll go with you after. Ahora voy contigo, que levantaste la mano.
Okay, so I really like the system, but I have two questions. So the first one is, in terms of energy consumption, the system, how much it consumes per year? Because as we know, now the world is running out of energy, as we can see the energy problems that Europe has now. And my second question is, you say about the CO2, and you talk about like if I save CO2 or I spend less, I produce less CO2, I will get some coins. You say something like that. And my question is, do you think that a system of coins will be a good idea to develop a system of coins with blockchain in cryptocurrency?
It's being done, but I can't do it because I'm the developer of this. So if I try to do, people might think that I'm trying to monetize myself by using this technology, and as I told you, it's open source. Everyone can use it. There are 2 companies that are doing this attached to Evalua. One is in Colombia and the other one is in France. But they just contact me and I say, okay, go ahead. That's for the second question. And the first question, I couldn't get it. Could you say it again?
So we know everything needs energy. So in terms of energy consumption, your system, how much does it consume per year?
Everyone needs energy. That's what I got.
Like your system needs energy.
Oh,
because it has
okay.
a processor.
Okay,
so
okay.
in terms of energy consumption, how much it needs per year?
Excellent question. Yeah, that's a very important issue. If you are going to use energy, you need to be sure that the use of energy is less than the one that you are measuring, of course. You know what is good about these small computers? I might call them computers. These small computers, they use very few amount of energy. And the best thing that they provide you with is that you can turn it off. While you're measuring, for example, energy, you need to measure it every second. Because if someone does like this and like this in any machine, you need to know how much consumption you are involving in that action. You see? So you need to measure every second. The system, I'm going to give you technical details. The system uses 16 milliseconds to capture how much energy is being used. And the rest of the second, it turns off. It doesn't work. You see? And that's the way we save energy. This thing, you can feed it with a solar panel. We have done it like this big. Okay? Got it? Any other question? Please, por favor. She needs the microphone. And we're going to be done because we are running out of time.
Muchas gracias por la conferencia. Yo quería consultarte, me parece muy interesante. Gracias. Pregunta, ¿en cuánto estimaría que las personas adaptemos a esta nueva tecnología, ¿no? Usted hablaba de generar una huella de carbono de cada persona, ¿no? Entonces, viendo nuestra realidad en Perú o en Latinoamérica, ¿cuánto tiempo usted estimaría que nos adaptemos a esto?
I will give you the short answer. It's going to happen in 2030, and I'll tell you why. I don't know if you're aware what happened in the COP21, Paris. It is called El Acuerdo de París. All the countries went through that. All the countries in the world went through that. Even the United States that was reluctant to do it. Your question was in Spanish, so I better answer in Spanish. El Acuerdo de París lo presentaron, o todos los países se presentaron al Acuerdo de París. Solamente Estados Unidos dijo que no estaba de acuerdo, pero fue temporal. Ahora ya están allí dentro del Acuerdo de París. Todas estas medidas que se le están imponiendo a los países, imponiendo no es la palabra, se las están sugiriendo. No vienen de ahora, vienen desde Kioto 1997. Ustedes ni habían nacido. Desde ese momento los científicos dijeron, tenemos un problema grave asociado a la producción. Y nadie paró bolas. ¿Se vieron la película Don't Look Up? ¿No miras hacia arriba? Well, eso es lo que está pasando desde 1997. Ahora tenemos este problema. ¿Y por qué te digo que va a pasar en 2030? Los países tienen, inclusive Perú, tiene plazo hasta 2030 para declararse carbono neutro. Y eso no va a ocurrir hasta que midamos. Y cuando midamos se van a dar cuenta que se saltaron una parte muy importante. Las regulaciones ahora dicen que son las empresas las que generan CO2. Pero se comieron ese 10%, que es el único 10% que crece día a día, queramos o no. Las empresas pueden crecer, pero también pueden ponerse más pequeñas e incluso irse a la bancarrota. La humanidad crece y crece y crece. Y entonces aquí tocamos un tema vital, natalidad. En 2030 me vas a oír, no en mi voz, probablemente alguien que tome decisiones va a decir definitivamente nos tenemos que involucrar los humanos en este problema y vamos a tener que controlar la natalidad. ¿Respondí tu pregunta? Your jobs. The reason why I want you to be here is because your jobs are going to be dominated by this. Right now, there is a lack of people working in this field. Ahora mismo hace falta gente que trabaje en estas cosas. Las está pidiendo la ONU, no Fernando Yepes, la ONU. Y sus trabajos van a estar dominados por esto. Si ustedes trabajan en tecnología. Bueno, y si no, también. Any other question? Okay, I'm done for today. Mr. Héctor Flores, thank you so much for the opportunity. To complement your question, this is the interface of Evalua. Now we are watching it in Spanish, but it exists in English and French as well. Okay, thank you so much, Madam. We need to see the video. For the audience online, we are going to see the last presentation. Oh, any question from the audience? No chat? No questions? Okay, thank you so much. Sandra Marcela?
Yes.
Okay.
Good afternoon.
Excellent. How are you, Sandra? Say something.
Fine, thanks. Fine, thanks. Okay. You can see my slides.
Yes, that was very fast. Okay, Sandra, so now you're the owner, you are in control. Go ahead, please.
Okay. Okay, thank you.
Can you start, Sandra, by saying your title, because I'm exhausted. Thank you so much.
Yes. Thank you. Okay. Good afternoon, everyone. I am happy to be here. Today, I am going to talk about my research called Team Productivity in AI Software Development. The authors are Giovanni Hernández Pantoja from Universidad Mariana, and Marcela Guerrero from Universidad de Nariño in Colombia. Okay, in my presentation, I will focus on 6 main sections: problem, motivation, methodology, results, conclusion, limitation, and future work. Okay, the problem. Productivity is an economic measure created at the end of the 15th century. In software engineering, it began to be studied in the late of 1917. The conception of productivity is associated as the ratio between the outputs, set of code lines, characteristics and function, and the inputs, time and effort. But when we talk about agile software development, this perception changes. Therefore, we identify the next problem, how to evaluate team productivity in agile software development. And the symptoms identified are limited information about team productivity in agile software development. The perception of productivity changes according to the role. Teams generate data permanently without a unified view of productivity. Next, the values and principles exposed in Agile Manifesto are abstract to measure team productivity. And finally, the information generated by teams is expensive when translated into decision. And the causes identified are little clarity in the concept of team productivity in Agile software development and how it can be measured. The values and principles are not worked as practice for measuring productivity. The resource and effort invested exceed the benefit generated by the decision made, and productivity concept based on traditional software models. Therefore, our motivation for this research is characterizing a conception of team productivity in agile software development through a systematic mapping study. Methodology, to conduct the systematic mapping study on team productivity in agile software development, the present study is guided by the systematic, orderly, replicable, and methodical process proposed by Petersen. The stages considered in this process are detailed in this figure. The number one state defining research question. The research question selected for this study on team productivity in AHD are: how many primary studies describe the concept of team productivity performance in AHD? Number two, what type of study do the articles found refer to? Number three, where do primary studies come from? Number four, what is the publication frequency of studies that describe the concept of team productivity in AHD? Number five, in what contexts are found the conception of team productivity in AHD? And number six, what methods of agile software development are contemplated in primary studies? And number seven, how do primary studies define team productivity in AHD? And number eight, how is team productivity measured at AHD? The number two is defining a search stream. In this phase, we build a search stream considering the previously defined scope and the research question. The streams include the terms and Boolean operators shown in this figure. The bibliographic databases consulted were IEEE Explore, ACN Digital Library, Scopus, Compendium, Web of Science, and Springerlink. Depending on the databases, the query parameters were adjusted. The number three was defining inclusion and exclusion criteria and search filters. The classification scale was based on the application of the inclusion and exclusion criteria and the defining filters in order to select the most relevant papers. The inclusion criteria were studies published between 2001 and 2021, complete studies published in journal, conferences, or congress with our peer review, studies published in English, studies related to productivity in agile software development, and studies that are reported as primary studies. For the current research, it was decided to consider the studies signed to 2001 because from this day, the agility trend started to develop to do the consolidation of manifesto for agile software development. The chosen selection strategy applying inclusion and exclusion criteria is shown in this table. The number four is search execution. In this phase, we use the search stream. Also, we consider the publication date, the language, and the type of content. It's important to mention that in IEEE and ACN Digital Library, it wasn't possible to filter by language because this functionality was not available. Moreover, in the case of the Springerlink, the discipline and discipline were considered according to the type of content. For example, studies like conference paper, the selected discipline was computer science and the subdiscipline was software engineer. While for the studies whose type was article, the selected discipline was computer science and the subdiscipline was software engineering, programming, and operating system. The next one was reviewing the title, abstract, and keywords. In this phase, the title, abstract, and keywords of each selected studies are read. It should be noted that in case of keywords related terms were considered, which varied according to the age search engine. The next step was removing duplicate studies. Next, we read the introduction, results, and conclusion. And finally, we read the full paper. In this figure, you can see the results obtained by each search engine, applying each filter mentioned. Next one, quality evaluation. In this phase, we considered a set of criteria shown in this table for quality evaluation in the selected papers. The criteria were report quality, rigor, credibility, and relevance. To evaluate the quality of the articles, a scale was established as follows: high 2 points, medium 1 point, and low 0 points. The relevance criterion was related to the evaluation given by other research to the study. The number of citations it has was taken as follows. For example, greater than or equal 10 citation, high 2 point, between 1 and 9 citation, medium 1 point, and no citation, 0 points. The papers with a score equal to or greater than 80% of the total possible points were finally chosen. Next one, results. In this figure, you can see the results obtained by search engine in each applied filter. The number one, the number of current studies was 8 articles. The titles of the selected articles can be viewed here. The next, second question related to the types of study, we identify 62.5% are studies presented at a conference or in a journal. Number 3, the primary studies come from 50% or investigation from European continent, 25% from the Asian continent, 12.5% from North America, and 12.5% from Oceania. Number 4, the publication frequency or studies that describe the concept of team productivity in AHD is between 2018 and 2021 with 67.5% of the articles. Number 5, the context of team productivity conception in AHD. All the articles come from studies development in the field of the software industry. Number 6, the methods of agile software development that are contemplated in primary studies were Scrum, Stream Programming, and Canva. Number 7, the definition of team productivity in AHD in the literature is an abstract concept. Its meaning is still being studied and is under construction. For software organization, team productivity in AHD plays a fundamental role because they consider it's an indicator of improvement within their process. Team productivity is composed of a set of factors of distinct types that generate an impact with the team, the organization, and even the market. It also visualizes customer satisfaction through the functionality and quality delivery of a software product according to their expectation and needs. Number 8, how is team productivity measured at AHD? The investigation identified in the selected study 63 factors that influence the measurement of team productivity in AHD, which were organized into 4 categories: meaning, impact, flexibility, and high performance. The meaning category includes the factors that are related to the perception that the members of the development team had about productivity, which can be seen from an individual approach or from a general perspective. The category impact category, the factors that affect within the team and that generated a negative, positive, or even neutral influence of this behavior. Flexibility category, in this category are gathered the factors that affect the performance of team when it is subject to conditions that imply changes that is adapt to change. And finally, high performance factor related to the capabilities that consolidate the identity of the team and contributed to achieving higher levels of performance. Conclusions. The systematic mapping study conducted on 6 information sources, IEEE, ACN, Digital Library, Scopus, Compendium, Web of Science, and Springer Link, allow the identification of 8 primary studies with 63 factors to measure team productivity in agile software development. Based on the studies analysis, an approximation is made to the definition of team productivity in AHD. highlighting that it's an abstract concept of great relevance for software organizations since it functions and as an indicator of continuous improvement. In addition, team productivity in ASD has factors that generate an impact and allow the achievement of objectives associated with customer satisfaction. The identified factors were classified into 4 categories, meaning impact, flexibility, and high performance. And limitation and future work. The main limitation of this study was the bibliographic source of information, such as its Weiler or Sandiret were not considered. It would be interesting to replicate in this research, included these search engines. As future work, it's intended to make a contrast between the conceptualization of team productivity in ASD along with the factor for its measurement established in this study with the appreciation obtained with the member of ASD teams. Thank you so much. Any question?
Thank you, Sandra. We are now open for the questions. Any question? There is a question over here, Sandra, so don't leave, please.
Okay, thank you.
Thank you for your presentation. It was very interesting. I was wondering if you also looked at the productivity at different points in the software development life cycle. So are the developers more productive in the beginning or in the end when, or should I say the bitter end as the product is closing up? If not, perhaps that's an idea for future research. And then other wacky ideas like, are software engineers more productive in cold weather climates when they can't go outside and enjoy themselves? Thank you.
Okay, thank you so much.
Sandra, is it all clear?
Si me podrían ayudar con la traducción, estaría agradecida.
Sí, el doctor pregunta si ustedes tuvieron la oportunidad de ver si, como están trabajando con productividad, si pudieron ver si la gente era más productiva al principio o al final. Let me try to complement with him. That was part of the question. And the second part? The second part was just a suggestion for future research about whether or not it's physical factors. Okay, where to go? And when you say physical factors, what do you mean by that? Like, are they working in an office? Are they working in a cold weather environment? Are there other impacts on software engineering productivity, cold side things? Okay. Sandra, cogiste lo primero. Lo primero es si tuvieron la oportunidad de saber si la productividad era mejor al principio o al final de un inicio de proyecto. Y la segunda es si factores externos como que si trabajan cierta cantidad de horas dentro de un lugar, fuera de un lugar, también afectaban.
Sí, pues bueno, mi inglés no es tan bueno, voy a tratar de responder la pregunta en español. El mapeo sistemático nos permitió a nosotros indagar sobre el concepto de productividad. Como tal, para poder decir si es mejor antes o después, los artículos no nos brindó esa información, solo pudimos identificar una definición muy general, así como también algunos factores. Entre esos factores sí está relacionado mucho a los factores, por ejemplo, de la velocidad, de la cantidad de trabajo, de cómo un equipo puede desenvolverse en un entorno de acuerdo a un ambiente externo y demás. Eso es lo que la información recolectada dentro del mapeo sistemático nos pudo brindar. Esperamos que en la segunda fase, con la aplicación de una encuesta, podamos definir exactamente qué piensan los desarrolladores de software sobre productividad y finalmente hacer un contraste para poder medir productividad y que esto aporte a los equipos ágiles.
Okay. I guess I'm the official translator now. You got it. Yeah, he speaks Spanish, so thank you so much. Sandra, where are you from?
Colombia.
Sí. Sí. Okay, Sandra, any other question in the audience? Hector Flores coming with a very difficult question.
No, this is a very easy question. Hi, Sandra. Very nice presentation, very nice research. Based on these results, I mean, based on the literature review about agile software development, finally, which agile methodology is most recommended to get the best possible productivity?
Ok. Con relación a la pregunta, bueno, en la revisión sistemática identificamos 3 metodologías ágiles, que fue Scrum, programación extrema y Kanban. Diríamos que Scrum fue la más votada, con un 50% de los estudios. Esperamos que, pues, no sé si al hacer el contraste ya con las percepciones recolectadas, en los equipos ágiles también sea la más usada, pero hasta el momento Scrum es la más relevante. Con el 50% de los estudios obtuvo la puntuación más alta.
Okay, thank you.
Clear like water. Sandra, Hector was very satisfied with your answer. I got a couple of questions for you. Only one, because the people here are tired, so we are going to let them go. Sandra, if I got it well, Agile is a platform for project management. Correct me if I'm wrong. Ok, lo voy a decir en castellano.
Sí, por favor, gracias.
Sí, no sabía que mi inglés era tan malo. La audiencia aquí se sonríe todo el tiempo y yo no sabía que era que no entendían. Sandra, si yo entiendo bien, Agile es una plataforma para project management, para manejo de proyectos. ¿Estoy en lo correcto?
No. Yo cuando estoy hablando de Agile se refiere al desarrollo de software ágil, al desarrollo ágil de software como tal. No como tal, Agile es un enfoque como tal de dentro del desarrollo ágil de software, no como una plataforma. Agile es un enfoque en ingeniería de software como tal.
Yo lo he visto siendo usado en una cantidad de proyectos que no tienen nada que ver con software. Por eso te lo preguntaba, pero además hay plataformas que te ayudan a seguir la metodología. Creo que eso es lo que es correctamente, ¿verdad? Una metodología.
Sí, es que realmente, por ejemplo, hay muchos métodos ágiles, por ejemplo, Scrum. Ese es un método ágil que no necesariamente está construido para desarrollo de software, sino para proyectos de gran complejidad. Entonces, uno de los, inclusive, pues desarrollar software es de gran complejidad. Entonces, Scrum se puede adaptar en diferentes ámbitos. Asimismo, hay otros métodos que son adaptables. Y esa es una de las ventajas que uno puede aprovechar y proveer de esos métodos. Entonces, eso es lo que, pues, puedo decir.
Ok, ya respondiste a mi siguiente pregunta, que era ¿cómo es que llegaste a utilizar esa metodología en tu investigación? Muchísimas gracias, Sandra.
Vale, muchas gracias a ustedes. Thank you so much.
No problem. We're done. Okay, we closed the event, isn't it? This is the very last presentation. Do we have anything else to do, Mr. Hector Flores? Okay, so that's something like drinking, dancing, having fun. Okay, so we are gonna have a boring event for finishing. Thank you so much for coming to all the audience. Now, Neely, could you tell me the time? 5 p.m. We close the event. I can see the clock here. Thank you so much for coming to the 16 people in the room. Thank you so much for coming, you students over here. Now is the time to clap.
Wait, please, people in Zoom, you can connect at 6 p.m., please. We will give a very brief presentation about the conference closing. 6 p.m.
Okay, that's the invitation. The invitation is open to everyone online in the conference that join us online. You are invited to join us again. The very, very brief presentation of the event ending. Thank you so much for coming. I will see you all in 20 minutes. Bye-bye.
Para explorar nuevas áreas de conocimiento. Hay aspectos que debería interesarnos como futuros profesionales e ir ya mirando qué líneas de desarrollo podríamos tener ya como futuros profesionales, ¿no? Y justamente quería yo aprovechar esta última sesión para, en principio, agradecer la visita de Héctor, de Fernando, de Florencia, de Camilo, creo que todavía está Camilo, sí, por habernos apoyado en la organización y también obviamente llevar adelante este evento, ¿no? Nos gustaría obviamente continuar con esto porque, como les decía, esta es la primera vez que viene esta conferencia internacional aquí a Arequipa, a Perú, ¿no? Y queremos seguir en esa línea, explorando también nuevas oportunidades, tanto para docentes como para nuestros estudiantes, ¿no? Entonces, como un reconocimiento a todo el trabajo que ustedes han desarrollado, queríamos ofrecerles un pequeño presente. Si me permites, en principio, Héctor. Muchas gracias. Un pequeño presente como souvenirs para que tengan en la memoria la visita que han hecho a Arequipa y sobre todo a la Universidad Continental. Son seguramente algunos pequeños regalos con souvenirs típicos de nuestra ciudad, ¿no? Igualmente, Fernando, muchísimas gracias. Ay, perdón. Florencia, ¿dónde se fue? Florencia, por favor. Igualmente, muchísimas gracias.
Muchísimas gracias.
Camilo. Igualmente, Camilo, muchísimas gracias. Un presente. Y bueno, no sé si…
Bueno, pues
muchísimas
gracias Henry, muchísimas gracias a la universidad. Realmente para nosotros es una gran oportunidad, ¿no? Contar con este tipo de espacios, con una universidad y un grupo de personas académicas interesadas en fomentar este tipo de eventos que van a apoyar la internacionalización, la colaboración, ¿sí?, de conocimiento en una comunidad latinoamericana y por supuesto con invitados bastante especiales de otros continentes, ¿no? Entonces, muchísimas gracias Henry y a todo el equipo de la universidad, pues, por la organización, por la ejecución del evento, Por supuesto, muchas gracias por el compromiso. Deben saber que este trabajo colaborativo junto con la Universidad Continental empezó en enero del 2022. Quiere decir que esto no es un trabajo de un mes, 2 meses. Esto está preparado desde hace más o menos 10 meses. Así que pues muchísimas gracias por todo el compromiso, toda la colaboración. Gracias.
¿En qué idioma estamos hablando ahora? Muchísimas gracias, Henry. Y bueno, a mí no me gusta recordar los malos momentos, pero llegué como bravo yo, ¿no? No sé si se acuerda la primera oportunidad. Y alrededor de eso yo quería dejarles el mensaje de disculpa sobre todo. Y lo que voy a decir no es una justificación. Desafortunadamente o afortunadamente, en principio yo pensé que esa oportunidad que me ha dado la vida de irme por el mundo dando vueltas iba a ser una cosa buena, pero eso ha jugado en contra mía por alguna razón. Y es que cuando te bajas en Australia, vives en Australia, te das cuenta que la gente de allá no es mucho mejor. La educación que reciben tampoco, son gente de una educación bastante promedio. Te vas a Francia, vives allí, te das cuenta que tampoco son pues muy buenos en lo que hacen, al menos no a nivel individual, pero tienen esa facilidad para trabajar en equipo y se logran entender muy fácilmente. Esa frustración que mostré yo al principio no es una frustración que derive del ego, sino de la incapacidad que tenemos de trabajar en equipo. Me frustra muchísimo porque aquí hay gente muy capaz, pero no logramos trabajar en equipo. Quería ofrecerle mis disculpas y que entienda que yo nunca he sido una persona egocéntrica. Es eso, que me desespero con toda la capacidad, que no hagamos unas cosas superlativas. Pero bueno, estamos en ese camino, Héctor, Flor, estamos, Juan, y bueno, lo vamos a lograr. Yo estoy seguro que lo vamos a lograr. Muchas gracias por la oportunidad.
Muchas gracias, Fernando. Y bueno, quería también...
Bueno,
adelante.
yo quiero agradecerles también, la verdad, la hemos pasado hermosísimo. Les quiero dar las gracias a ustedes también. Bueno, creo que todas son experiencias y de todo se aprende. Quiero decirles, chicos, que aprovechen, que investiguen, que investigar abre la cabeza y los posiciona en un lugar mejor y que es parte del plan de formación de ustedes, que sirve no solo para quienes se quieren dedicar a investigar, sino para quienes quieren hacer actividad privada, los eleva, les permite tener una mirada diferente del área disciplinar en la que estén, no solo para las actividades de informática. Quienes estamos asociados a la informática muchas veces bregamos porque hacemos práctica y bueno, el que practica no investiga, y sin embargo la investigación es una de las mejores conductas que podemos tener quienes hacemos práctica. Así que bueno, los invito, muchísimas gracias por todo, me sentí muy cómoda. Así que desde ya, un placer y hasta la vuelta.
Bueno, para completar el cuarteto, entonces pues yo también quiero reiterar los agradecimientos a los anfitriones. Yo sé que, o sea, en estos 2 días que hemos estado aquí, pude ver pues de primera mano que todos están aquí como hormiguitas, o sea, incluso los que de pronto están ahí metidos, de pronto pues en algunas situaciones se han presentado algunos inconvenientes, pero pues eso también nos deja aprendizajes y digamos que se ve mucho el esfuerzo como por lograr que el evento haya salido bien. A los estudiantes los que nos acompañan, los que nos acompañaron ayer o hace un rato, pues también reiterarles que este tipo de eventos pues hay que aprovecharlos porque pues es una oportunidad como para intercambiar ideas, conocer qué están haciendo académicos, otros estudiantes pues alrededor del mundo, pues aprovechando los que nos visitan aquí, bien sea presencial o virtualmente, y bueno, pues seguir aprovechando y que esta sea como tan solo el primer paso como para que haya más actividades de cooperación entre nuestras instituciones, no solamente los anfitriones y los organizadores, sino pues todos los que han venido participando. Entonces, pues muchas gracias a todos por el aporte, que cada uno de nosotros haya hecho al final, todos al final que hemos aportado. Y pues nada, pues disfrutémoslo todos. Muchas gracias.
Bueno, muchas gracias. Entonces, quería yo aprovechar también esta oportunidad y quería felicitar a los visitantes del Ecuador y quería también darles un pequeño presente. Si uno de ustedes se aproxima, por favor, porque nos impresionó con su voz, ¿no? Un pequeño presente de la ciudad de Arequipa. Felicitaciones también por su presentación. Bueno, para cerrar entonces, por favor, les pidamos con un fuerte aplauso. Esperamos a las 6, ¿no?